This is problem 1 for FA1. So in this problem, we know we have continuous force, 18 newtons. No? This is applied force. And we have displacement and time duration. So we are asked to find the mass of the ice and the displacement for the next 5 seconds. Now, as we can see what will happen here. So, kunwari ito yung block of ice. So, we know na merong applied force na 18 newtons. So, continuous yun. Continuous yung applied force. No? So, since constant yan, we know that meron tong constant acceleration. So, the first thing we need to do is we need to identify first the forces acting upon our object, which is the ice. So, kunwari ito yung center of mass ng ice. We know that the only force acting upon that object is the ice, and we know that it's 80 newtons. So, our net force is equals to 80 newtons. So, since we know the net force already, we know that this net force is being affected by the mass of the ice and its acceleration. So, we know that this object is accelerating since we have a net force 80 newtons. No? However, we don't know the mass yet and we don't know the acceleration. So, wala tayong ibang clue for the mass, but we have clue regarding the acceleration because we have the displacement and we have the time duration. So, if you can remember, we have 3 equations for the uniformly accelerated motion. No? So, since the acceleration is constant, we know we can use those equations. So, to recall, we have the first equation that we have is the acceleration is equals to the difference of the final and initial velocity over the time duration. And we also have that the displacement is equals to the initial velocity times the time duration plus 1/2 80 squared. Then our third equation is the difference of the squared values of the final velocity and the initial velocity over twice the acceleration. So coming from here, we know that we have displacement and we have time duration. So we can use the second equation to find the acceleration. So in finding acceleration, we use the second equation. We have displacement is equals to the initial time plus 1/2 80 squared. So we know that the ice started from rest. So this one, it means that the initial velocity is 0. So we can equate the equation, can find the acceleration is equals to twice the displacement over the squared value of the time duration. So it's equals to twice the 11 meters over the squared value of 5 seconds. So we can find the acceleration is equals to 0.880 meters per second squared. So since we know the acceleration, we can find the mass of the object. So we have the net force, we have the acceleration, so we can find the mass. So from the equation, the net force is equals to the mass times acceleration. We can find the mass is equals to the net force over the acceleration. So it's equals to 80 newtons over 0.880 meters per second squared. So around 90.9 kilograms. So we have three significant figures, so we can now find the mass. So we know that the ice weighs 90.9 kilograms times the acceleration due to gravity. But since we just need the mass, we have 90.9 kilograms. So what happens to the ice? No? So before we answer the second question, we know that on the first 5 seconds, it is accelerating with a rate of 0.880 meters per square second. So it displays 11 meters. So 11 meters yung na-travel niya given na ito yung acceleration na. No? However, sabi dito, dun sa letter B, what if after 5 seconds, natapos na or tinigil na yung pagtulak dun sa ice? So at this point, the net force is now equal to 0 and we cannot just compute for the total displacement for the 10 seconds, no? Because on the first 5 seconds, we have acceleration. Then on the 6 to 10 seconds, we don't have acceleration. So we know na kung ano yung velocity niya at 5 seconds. So that velocity will last for eternity, you know. So since we know the first law of motion, inertia, so the state of motion will not change. So for us to be able to find the displacement for the next 5 seconds, we need to find the velocity. So for us to be able to find that velocity, we can identify the final velocity for the first 5 seconds and use that velocity to be the initial velocity for the part 2. So I'll just copy this. So sagutan natin dito sa next page. So to find dito sa letter B, so dun sa second part, it's time is equals to 6 seconds to 10 seconds. So we need to find first the velocity at 5 seconds. So alam natin yung velocity ano. So anong velocity dito? So we can use the UAM equations to find the velocity here so that we can know starting from here, ano na yung displacement na. So means at this point, the net force is now equals to 0. So hindi na yan nag-accelerate. So for us to be able to find the final velocity, we know that at this point, the initial velocity is 0. Then it will accelerate with a rate of 0.88 meters per square second. So we can use the third equation. Pwede. Pero pwede din natin gamitin as simple as the first equation, no? Kasi alam naman natin yung time duration, it's 5 seconds. So alam natin na with this acceleration, pagdating sa final velocity, we have certain velocity. So we have certain velocity. So let's find out acceleration is equals to the delta V or the final velocity minus the initial velocity over time duration. So it's equals to, if we equate that, we can find the final velocity is equals to alam natin the initial velocity is 0. So the final velocity is 0.880 meters per second squared times 5 seconds. So we know that the final velocity is 4.5 4.40 meters per second. So alam natin, nag-accelerate yan. Simula speed na 0. Pagdating dito, so 4.40 meters per second since nag-accelerate tayo, 0.880 meters per square second. So what happens here? So since we know that the final velocity here is 4.40 meters per second, this speed will last for eternity. So in the ideal situation, so it will continue to move with this speed 4.40 meters per second. So it will continue to move and move and move and move until may outside force or may net force na mag-apply tayo. Pero wala naman sinabi dito may net force. So we know that it will travel with the same speed, 4.40 meters per second for the next 5 seconds. But the question here is, saan na siya nakarating? Saan siya nakarating with that velocity? So we can use as simple as the UAM equation 2, pwede din. So pwede din yung, we can also use the formula of the displacement over time is equals to the velocity. So we can use this formula, no? We can use this formula. Saglit lang. So we can use this formula na the displacement over time is the average velocity. So bakit pwede natin itong gamitin? So we know kasi na the velocity is constant. So kung constant yung velocity, kahit anong nilagay mo dyan, ito pa rin yung average velocity niya. So we can now find the displacement. So it's equals to the velocity, average velocity times the delta t. So again, displacement niya is equals to 4.40 meters per second times 5 seconds. So the displacement is equals to 22 meters. So itong 22 meters na to, dito yung initial point na. So from this point, mapunta dito at 22 meters, nag-display siya for 5 seconds. Okay? So hindi mo ita-times 2 lang yung 11 meters dito. You need to find the displacement using the velocity. Actually, pwede din yung yung second equation, no? Displacement is equals to initial velocity times time plus 1/2 AT squared since the initial velocity is 0. So you can get the same answer. No, the initial velocity, ulit. The initial velocity there is no longer 0, it's the acceleration that is 0. So you can find the initial velocity times time plus 1/2 AT squared since the acceleration is 0. We have the displacement is equal to the initial velocity times time. So we can see that the equations are the same. No? So we can get the 22 meters. So that's how you will solve the first problem.